Well. Shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
This episode of Space Nuts is brought to you by the Dollar Shave Club, a quality shave without the big price. Just visit dollarshaveclub.com/nuts so they know you came from us, and you'll get a special introductory deal. dollarshaveclub.com/nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and welcome to Space Nuts, the podcast where we talk astronomy with Dr. Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Good day, Andrew. How are you doing?
I'm very well, and you? A lot better than I was a week ago, I'll tell you now.
Yeah. You do sound certainly quite a lot better than you were, given that you could barely speak last time.
Oh, wow. You know, the magic pills that are available these days are incredible, but I think it just comes down to accepting your fate and just resting up. I had to skip the first 2 rounds of the local golf club championships, which disappointed me tragically, but you've got to look after yourself at my age, son.
Thanks, Dad. Thank you.
Now, this week, we're going to talk about gravitational waves again, simply because they've made the news again for another reason, something to do with colliding neutron stars. We'll find out what that's about. There's also been a ring discovered around a dwarf planet, which would seem a little bit out of the ordinary. And have we found a missing Mars lander? Fred will be able to tell us very, very soon. But first up, Fred, gravitational waves. I did see some graphic animation on some of the news services this week, which were clearly discussing this. This has been quite a discovery.
A very big story indeed, Andrew. And it sort of comes hot on the heels of things we've talked about before, excuse me, because the detection of gravitational waves has been something that has been going on now for almost a couple of years, actually. Yeah, 2 years since the first one was detected. Using a pair of instruments in America called LIGO, the Laser Interferometer Gravitational Observatory. It's basically what this thing does is uses lasers to detect this very slight shaking of a massive object on Earth, and it's a big weight with mirrors attached to it. Excuse me. Sorry, I've got what must have caught it off you.
Digital flu.
Digital flu. So the two sensitive devices in America, the LIGOs, use lasers to detect very slight changes in position of the mirrors actually in the system, and those changes in position are caused not by trains going past or anything like that. All that vibration is actually taken out of the equation. They're caused by space itself shaking. Now, space doesn't shake very much. It was Einstein who told us that space is not rigid, but it is very, very nearly rigid. It's billions of times more rigid than steel. And so it takes a very big event to cause ripples through space, which we refer to as gravitational waves. But so far, we've seen a handful of those which have been caused by very distant, and by that I mean more than 1 billion light years away, distant collisions of black holes. Now, black holes typically in the range of 20 to 50 times the mass of the sun. So these are fairly big objects. They're a long way off. They coalesce with spectacular rapidity, actually, just because they're so massive. And you get this pulse of gravitational waves. So those are what have been detected so far. Recently, the duo of these two detectors was joined by a third one, which is in Italy, and it's called Virgo. What that's done is increase the sensitivity, excuse me, but having this third detector well separated from the other two means that you can now kind of triangulate to get a direction that these gravitational waves are coming from, because that wasn't really possible before. All you knew was it was northern or southern hemisphere. But now with the Virgo one, you can pin it down actually to an area, I think we've mentioned this before in a previous episode, an area about 300 times the area of the full moon. So it's still not pinpoint by astronomical standards, but it's good enough that other telescopes can follow up on looking for what if there's a visible flash or something like that of the event. And so to get to the point here, back on the 17th of August this year, two neutron stars collided in a galaxy about 130 million light years away. So this is much nearer than the black holes that we've seen so far. But because of the addition of the Virgo detector, astronomers could pinpoint pretty well where these two neutron stars were colliding and the gravitational waves that they released. I'll tell you about neutron stars in a minute, but let me just go on to say that then allowed the world's telescopes to kind of home in on this area of the sky, starting with a gamma ray telescope in orbit above the Earth, but also an X-ray telescope, Chandra, that picked up the flash of these two stars colliding, and about 50 telescopes on the ground picked them up as well, including our Anglo-Australian telescope here in New South Wales. So that brought together a whole plethora of different kinds of observations. It meant we could see the visible spectrum of this thing. In other words, look at the this rainbow, this barcode of information that's in the rainbow spectrum, and from that work out what elements were being created in this flash. All of those great pieces of information came together. So that's the reason why this is such a big story. We've got lots and lots of telescopes of different kinds, and the gravitational wave telescope, because in a way that's what it is now, telling us exactly what happened. And that is why it's such a big breakthrough. We've seen these flashes before in visible light and things, and gamma rays too. And the theory has always been that they're caused by neutron stars colliding, but the proof has now come with the gravitational wave evidence. It's like pointing a microscope at these two objects as they come in together and seeing the intimate details of what's happening. And
so did this neutron star collision happen on the 17th of August, our time, or did we just detect the remnants of it on the 17th of August?
So what happened on the 17th of August was that the gravitational waves that have been traveling for 130 million years from this distant galaxy actually swept over the Earth. So the 17th of August, that's when this pulse arrived. It's a bit like, it's not a terribly good analogy, but it's a bit like throwing a stone into a pond and seeing the ripples spreading outwards from that. There's a time lag between when the stone hits the pond and when you receive the ripples on the shore. It's the same sort of principle, but it's 130 million years set of ripples. So those ripples washed over the Earth, and that's what we saw.
In astronomy terms, most likely we're going to see the ripples at some stage of these events, but not the events themselves.
Well, that's right. Except that the light information from the event and the gamma rays and all the rest of it, they arrive at the same time, effectively, because the gravitational ripples travel at the speed of light. So does light, so do gamma rays. What happened, in fact, there's a slight time lag. So the gravitational signal tells you what is physically happening to these two stars. And let me just explain that neutron stars, they're objects that have reached the end of their lives. They're typically about 20 kilometers across. They're tiny things, but they contain the mass of a star like the sun. So they're incredibly dense, very unusual objects. They have intense magnetic fields. These two neutron stars in the outskirts of this galaxy, they may have come from a smaller galaxy that has been swallowed up by the big one. So the two neutron stars, they've probably been colliding or coming together, maybe even for as long as 1 million years. But it's the last 90 seconds where they are spinning around one another, and their acceleration is so high that they start creating these ripples in space-time. So the last 90 seconds, you've got this ripple coming, which ends actually with a little what we call a chirp. It's the frequency goes up at the end and then stops because the two have actually coalesced. And the gravitational wave signal stops when they coalesce because there's no longer any accelerations taking place. But that coalescence corresponds with a huge mega explosion. And that's when the light pulse comes out and the gamma ray pulse. And so it is really a remarkable piece of work. It really is not an exaggeration to say that this opens up a whole new field of astronomy. The combination of visible light, gamma rays, all the rest of it, with the gravitational wave detection. So I think we are embarking on a new era, Andrew, and fortunately Space Nuts is here to tell everybody about it.
Yes, indeed, and who knows what kinds of doors that might open into the future as we learn more and more about these things. It's a fascinating realm, is the world of gravitational waves. And you're listening to Space Nuts. My name's Andrew Dunkley, and he's Fred Watson.
0G, and I feel fine.
Space Nuts.
Now on Space Nuts, we're going to look at a dwarf planet that's exhibiting signs of having its own ring system, which you would think is a little unusual in the scheme of things. I mean, we look at Saturn as a glaring example of a ringed planet. It's a gas giant, but this one that they've discovered, and we're talking a few years ago now, is not quite as spectacular in terms of its volume as Saturn, but it does have a ring system, which obviously would create a lot of questions, I imagine, Fred.
It does. It's actually a really remarkable piece of research, is this, because this particular object, its name is Haumea. It's a potato-shaped object, not quite spherical. But it is one of the reasons why back in 2006, astronomers took the decision to reclassify Pluto, not as a planet, but as a dwarf planet, because Haumea is one of this cloud of large icy asteroids, of which Pluto is a large example, that orbits beyond the orbit of Neptune. It orbits the Sun out there in the distant depths of the solar system. So they're called, with great clarity, trans-Neptunian objects because they're beyond Neptune. So this is one that was discovered actually, I think, back in the early 2000s. 2004 is when we found it.
Yeah.
It's about the same size as Pluto actually. Its large dimension is, I think, 2,300 kilometers. So a similar sort of size. But it's so far away. This thing is, at its nearest, it's about 6 billion kilometers away, way beyond the kind of detailed range of most telescopes. So all we see is typically a point of light. You can measure its color. We know about its shape because it rotates, and that changes its brightness over a period, I think, of 4 hours, its rotation period is. So how do you find out more about something like this, short of sending a spacecraft there? And that's, of course, a very big mission. That's what we did with New Horizons to get us to Pluto. The answer is you use whatever is available to you. And that means taking advantage of a phenomenon we call an occultation, which is to do with the occult.
Aha! Well,
So
this
the
sounds
word-
sinister.
It's very sinister. The word occult actually just means hidden. And so to occult is to hide. And an occultation is when an object in the solar system passes in front of a more distant object, and usually it's a star. So it's called an occultation. And what it means is that if you can predict that a body like Haumea is going to occult a distant star, then you can set up a whole array of observers on the surface of the Earth with their telescopes, basically to measure the brightness of the star as Haumea passes in front of it. And if you do that over a large enough area of the Earth, you can basically plot tracks that tell you more or less the shape and size of the occulting object. That's how we know. It's one of the reasons why we know it's an odd shape. And so that was done a few months ago. A whole set, I think something like 12 or 15 different observatories all over the Earth were watching this distant star. Haumea passed in between us and it, and they all recorded the dip in light that comes because the star is basically hidden by or occulted by Haumea. But the big surprise was that as well as getting these, this dimming from the planet, from the dwarf planet itself, there was a small dimming before Haumea occulted the star, with an equivalent version of the same thing afterwards. And what that's telling you is that there is a ring around Haumea. It's not a separate moon, because this was observed, I think, in pretty well all the observing stations. That they all saw this secondary dimming from the ring. It seems to be very dark. It blocks out really about half the light of the star as you're looking towards it. It's probably about 70 kilometers wide. It's roughly 1,000 kilometers from the surface of Haumea, but Haumea is such a weird shape, that varies. And it's really an extraordinary discovery, because we believe that many objects out there in space do have rings, but we tend to think, as you said, in terms of Saturn's ring. We know that all the gas giants have a ring. They're pretty feeble compared with Saturn's rings. Jupiter has one, Uranus, Neptune. But now we know that this small object out there in the depths of the solar system has this same ring of material round it. Celestial bling, as one of my colleagues called it yesterday.
That's
yeah,
clever.
I do too. Yeah.
Do we know what causes a ring to form? Is it a simple process?
There's still a fair bit of debate about this. So that the two possibilities for a ring are, first of all, is it just debris that is kind of the primordial debris of the solar system, the stuff that planets are made of, just shepherded into this ring formation by the gravity of the object there. In other words, it's swept up material from its surroundings, and its gravity has pulled it into a ring. That's one theory. The other one, and this is certainly one of the theories to account for the rings of Saturn, is that you've got maybe a moon of Saturn that gets too close to the planet itself, and its tidal forces just basically break it up. And so it breaks up into the ring structure that we see around Saturn now. So we really don't know with Haumea. It's in fact, as one of the scientists who's written about this says, the next step is explaining how that ring can form around such a peculiar body. Oh, and here's another little thing. I'd forgotten about this. The ring spins 3 times slower than the planet itself. That's a really weird one. Yeah. It's maybe not that weird when you think about it, because the spin of the planet is not directly related to the rotation of the ring, but it's an really interesting aspect of it. So great stuff. Once again, like the previous story, Andrew, this is a collaboration between many observatories in the world, all coming together to make a discovery that tells us something about things happening very, very far away.
And just to finish off, do we know how many dwarf planets have now been discovered? Is there a number on that? Because there seem to be more. I hadn't heard of this one, but there seem to be more and more popping up.
There's, I think there are 5, which, let me just get that right. So Pluto, Ceres, and then so Ceres is the largest object in the main asteroid belt. Pluto, of course, the best known object in the trans-Neptunian belt. But then there are 3 more, and Haumea is one of them. Makemake is another, and there is Sedna, I think, is the 5th one. So something like, 4 of those dwarf planets are way out in the depths of the solar system. The 5th one is part of the asteroid belt between Mars and Jupiter.
And this one is potato-shaped, which makes it more appealing.
Thank you. Ba-boom.
To get my weekly dad joke in. Yeah. You're listening to Space Nuts with Dr. Fred Watson, and my name's Andrew Dunkley.
Okay, we checked all 4 systems, and keying with a go.
Space Nuts.
Now, gentlemen, I've got the answer to finally making your life so much easier. Since joining dollarshaveclub.com, I don't need to choose between price and quality to get an amazing shave anymore. dollarshaveclub.com is a no-brainer for an incredible shave delivered right to your door. dollarshaveclub.com delivers high-quality razors right to my home. for less than what I used to pay. There's no reason to deal with the hassle of going to the store to buy expensive razors when you join the club. I think last time I bought a set of 4 razors, it was like $25 at my local supermarket, which is outrageous. Just go to dollarshaveclub.com and pick a razor that works for you in their line, and choose from their lineup of blades, and that's all there is to it. I get a first-class shave with my executive razor, and when I use it with Dr. Craver's shave butter, the blade just gently glides for the smoothest shave imaginable. Here's your chance to see why over 3 million members like me love Dollar Shave Club. Right now you can get your first month of Dollar Shave Club for as little as $5. After that, it's just a few bucks a month. Dollar Shave Club is so confident in the quality and value of all their products. There's no long-term commitment or any hidden fees. There's no reason not to join. Get yours at dollarshaveclub.com/nuts. That's dollarshaveclub.com/nuts. Now on Space Nuts, we are going to look at a missing Mars lander. Now, this search has been going on for a while. I do believe that the find has been made. Fred, we have discussed Beagle 2 once before, I believe.
We certainly have, yeah. So Beagle 2, the mystery lander. In fact, the details of this were released a little while ago, I think about a year and a half ago. But we've just had more information. That's why the story's resurfaced. So, but the main story goes back to 2003, when a spacecraft called Mars Express was sent by the European Space Agency to orbit the planet Mars. And that Mars Express is still functioning. It's still doing a great job of surveying Mars. On Earth, however, before that project took off, there was a Mars enthusiast, a British scientist by the name of Professor Colin Pillinger, worked at the Open University, and a Mars enthusiast, and very keen to send a lander to Mars, which would be equipped with the right sort of detectors to look for metabolic processes. In other words, he was interested in finding whether there was any signs of life on the red planet. And so he christened his spacecraft Beagle 2, managed to persuade people to put up the money for it. It was done on the cheap. I think its cost was only in the region of a few $1 million, which of course is very small for your average space flight to Mars. And he hitched a lift with Mars Express. Everything went well. The spacecraft was taken to Mars and was released from orbit on Christmas Day, 2003. Now, the plan was that Beagle 2, it had an aeroshell, in other words, a screen to protect it as it flew through Mars's atmosphere and slowed down slowly enough to deploy a parachute. Beagle 2 was deployed. It was sent on its way to Mars. An image was taken from Mars Express showing it receding into the distance. And sadly, that was then the last that was seen or heard of it, because what everybody expected was that when it landed on Mars, it was going to announce its presence by playing a track from the rock band Blur, which had been, I think, specially recorded for this. So everybody was listening out for this Blur track on Christmas Day, 2003. It never came. And, of course, Colin Pillinger was very, very disappointed. He always maintained that his spacecraft made it to the surface, I think because he was so confident with the technology that had been used. But most people thought that they'd got the atmospheric pressure wrong and the braking effect of the atmosphere was not enough for the spacecraft to slow down enough to deploy the parachute, and that it had just basically hit the surface at very high speed and was basically littering the surface of Mars. So now, fast forward a decade, actually more than a decade, because when the NASA Mars Reconnaissance Orbiter went into orbit, it actually was some years earlier, but people started using the high-resolution camera on board Mars Reconnaissance Orbiter, specifically to look for the wreckage, as everybody thought it would be, of Beagle 2. And in fact, what they did was they they calculated the Beagle 2 landing zone and had a pretty good estimate of where it would be. It was sort of something like 174 kilometers by 57 kilometers to start with, but I think they narrowed it down from that, and then looked down using this high resolution camera, trying to find some evidence of the wreckage of Beagle 2. So from 2006, when HiRISE was first deployed, the camera on board Mars Reconnaissance Orbiter, between 2006 and 2014, they took 26 images of this area looking for signs of it. But then a citizen scientist in Germany, Michael Kroon, is actually a former member of the Mars Express operations team. Yep. He noticed that there was a gap in the imaging and suggested that should be a place where people should look. The images within Beagle's landing area were not complete. So he basically put in a request for another image to be taken to cover this. And that happened in November 2014. And he noticed that the lander, or something that looked like it, might be there, about 20 kilometers from the original landing target, fantastically close. And so they spotted it. And then people started analyzing the images and realized that actually Beagle 2 had landed successfully, and its 4 solar panels had failed to open properly. One of them hadn't opened, and the one that hadn't opened was covering the antenna. And so even though it probably did transmit the signal from the Blur rock band, the fact that the antenna was covered up meant it never reached Earth. And that really was, I guess, a remarkable discovery to see that it did get there. It was successful, except that it didn't quite open its solar panels. There is new information as well, because there is an object that has been seen between different images from Mars Reconnaissance Orbiter. There's an object moving around, which they think is the rear cover of the spacecraft's aeroshell, which had a parachute attached to it, and it's probably blowing in the wind and moving around on the surface of Mars.
Oh, wow.
Quite extraordinary. Quite remarkable stuff.
You know, how typically astronomical is it for the only piece of ground that wasn't photographed to be exactly where it was?
Where it was, that's right.
I mean, that's almost as weird as sending a space probe to Venus, landing, having it unfold, and then have a lens clap melt to the camera so you can't take photos.
Yeah,
that's
correct.
happened. When you look at the list of tragic failures, I mean, they were almost not tragic failures. That's the irony in all of this.
And this certainly was. And there is one slightly, I suppose it's a poignant aspect to this. As I said, Colin Pillinger always believed that his spacecraft made it to the surface. Sadly, he died in 2014, a few months before this discovery was made. So he never knew that he was absolutely right, that Beagle 2 made it onto the ground and came within a whisker of being a successful mission.
That is sad, but I think he had enough self-belief to not have to be convinced.
Maybe that's correct, yes.
Fred, as always, fascinating. Thank you so much.
Great to talk to you, Andrew, and I look forward to talking next time with your newly found, ready-minted voice.
Yes, indeed. Yeah, it's certainly a lot better.
Prepared voice.
Improving by the day. You've been listening to Space Nuts with Fred Watson from the Australian Astronomical Observatory, and from me, Andrew Dunkley, thank you. Oh, hang on. One more thing before we go, Fred. I almost forgot. Remember a couple of weeks ago we were talking about Australia forming its own space agency?
Indeed we were.
And, we were trying to think of names like Australian Space Systems. Think about it.
Yes.
Well, somebody's come up with one, very cleverly, a name for the Australian Space Agency. You ready for this? Southern Hemisphere's Australian Space Agency. Short form. You ready? It's not rude, but it's typically Australian. Shazza.
I love it. Yeah.
I reckon that's a winner.
Yeah.
So if you've got a thought in mind for the name of the Australian Space Agency, see if you can beat Shazza. That's it, Fred. Catch you next week.
Sounds good. We'll be NASA and Shazza and the whole deal soon.
And the other ones we can't mention.
Yes, that's right.
Until next time, thank you again for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.
And this episode of Space Nuts was brought to you by the Dollar Shave Club, a quality shave without the big price. Just visit dollarshaveclub.com/nuts so they know you came from us, and you'll get a special introductory deal. dollarshaveclub.com/nuts.